Hello engineers. Today we are going to create a first Kotlin and Raspberry Pi project. We will use Kotlin, and so this is language as Java, use the same virtual machine, Kotlin compiling to Java classes and after that to bytecode. We will use Pi4J library and we will use remote debugging, so no need to launch that application directly on Raspberry Pi. Let's start from the beginning. First of all, we need to install IntelliJ IDEA on your computer. You can use MacOS or Windows, it's not necessary. If you don't have it, just Google it, IntelliJ IDEA, click to download, and we need a free version, so click other versions, and we need a community edition. It's totally free, full functional. We don't need some fancy extensions what IntelliJ IDEA has on Ultimate Edition. After you install it, the second step, we need to install the plugin for remote debugging. So as you can see, I have a Raspberry Pi. It's an old version. Raspberry Pi, I believe it's a third version, so it's on the same network. And just go to settings, go to plugins and search plugin, name it embedded Linux JVM debugger for Raspberry Pi. Okay, something went wrong. Restarted the, I believe I deleted it, so yeah. Okay, I did it for you. Go to settings one more time, plugins, embedded JVM, yeah. But do not forget about version. Version should be 1.24 because an older version they will not work with the latest IntelliJ IDEA interfaces. So I believe I already did it. Okay. Even install. Then okay, yeah. Yeah, so as you can see, we have two versions, 123 and 124. We need this one version. Okay, let's do it. So after that, create new project like Kotlin Pi4J, something like that. We need a Maven project and we need Java. We need Kotlin because Kotlin is more functional. Okay, let's create a new project. we can launch this code, but We don't need it. Okay, it works. Congratulations. Delete this code. Delete this one. First of all, we need some injections. Oh, let's connect our Raspberry Pi. So, one more time, go click here, edit configurations, click plus, and after you install this plugin, you will have a new configuration. You can go like my P, leave this port for default. Local IP address to my Raspberry Pi is 122.168.2.222. Okay. One second, please. Use your credentials. Click run as sudo and validate the connection. Okay, it's success. So you already connected to your Raspberry Pi remotely. And you can launch this code remotely. So it works. Okay. Oh, yeah. I forgot about one important moment. We should to not now, just do some preparations and create some packages, because Kotlin and Java, it's object-oriented languages. It's, on my strong opinion, it's much more powerful as Python, or what is a default language for Pi4J. Not for Pi4J, for Gpio and physical input-output, but it's much more opportunities when you use Kotlin. Okay, create some package like runtime, move your main class to this package, and create, I believe, in runtime package we create another package like something like setup for dependency injections. Okay. Now we will go and change the configuration. So choose your model, so it's the name of package of your project, and choose the way for your main class. Okay. Let's launch it again. Yeah, it's compiled with code 0. It means without errors. The second step, what we should do, we need some injections. Okay, let me copy some properties. So this is a Maven setup file. First of all, in section properties, inject something like that. But I believe we can look here. Yeah, example not, yeah, setup main okay, it's interesting. Yeah. The second thing, we need to inject some values for dependencies. Okay, yeah. So we will use Pi4J. We will use plugin compiler, Maven plugin compiler, and shade plugin version. This injection will be needed for fat jar to create a one single jar to push it to Raspberry Pi remotely and to pack all injections and all dependencies in one package. Okay. Then 1 second, please. I'm searching plugins. Yeah, I found it. Okay, we need some plugins. So in the section plugins, this is the end of the section. Install those packages, install those plugins. So it starts from here. Maven compiler to create fat jar. This is the same. I believe this is the same. Yeah, and this is section with dependencies. So we can synchronize Maven file, pom.xml, verify that it's synchronized without any errors, and then install dependencies, inject dependencies. Sorry, my English isn't perfect so far, but I'm trying. Okay, so from here we install some dependencies. Let's look on this. I forgot to install some dependencies, sorry. I told you about values. Here is it. And then synchronize it. Okay, so we have all what we need. Let's go to plugins. So we need some Apache plugins to create fat jar. This is for remote debugging and remote installation, remote launch actually, because when you use these features you don't need to work directly on Raspberry Pi, because here is very, on my opinion, useless configuration and idea. Okay, try to launch it again. Okay, so you can see it's building some jars, pack it into one package. The second thing, what we need in package setup, create some object like how it's calling injector. This is a companion object, so you can use it as singleton without create an instance. Create some functions like fun. We need a Pi4J configuration to work with physical input-output devices. Okay, and we need a console because under the hood Pi4J have a very powerful logging system, and you don't need to use actually log4j. Okay, something like get Pi4J console, and this is console. We need a console from Pi4J package because perfect. The second thing, and actually the main thing, what we need, Pi4J configuration, let's call it a context for, okay, create fun like a get Pi4J, mark it with the type context. Look, a lot of context present. We need a context from Pi4J. When you are programming Android applications, you will have another type of context, one more, but we need this one. And it's a Pi4J. Yeah, inject it, and we need new after context. Perfect. So this is kind of object-oriented architecture. It's a singleton of to get all needed dependencies. Let's start to program. Do not forgetting to comment your code. Something like Gpio. Kotlin Pi4J remote debugging. Perfect. Lesson 1. Okay. Creates init functions. Here we will initialize all our hardware resources because Pi4J, it's the bridge between your code and physical input-output Gpio interfaces. Okay, as we use Kotlin, we can use some later init vars. Okay, let's say hardware late init var like a Pi4J. It's a context context from Pi4J. We need a console to log out. Console from Pi4J, and we need actually at this lesson we will work with the simplest example, like a LED light. So we need a value for that to work with LED lights. What we do? Okay. In the next lessons, I will show you more detailed architecture. We will use a process for hardware setups, and we can switch it by in real time. So like add hardware config later. This is just for us because we will continue this project and fill it, extend it like that. Let init var, let output digital Yep. This class type comes from Pi4J as well. Okay, this is all what we need. Let's continue to fill our init function. So Pi4J. Now we can call our injector get Pi4J. Easy peasy lemon squeezy. The same with console. Injector get Pi4J console. So if you click here, it's already using. You can do it here. Okay, let me explain what we did. It's the same, but if you need to call to init Pi4J maybe a few times or get another ejections, it's a best practice, it's a good code style when you move it to some dependency injections packages. For example, in Android applications, we use DI presets, but here we created it manually. Okay, let's launch it. And make sure that it's already implemented. Okay, and this is our main function. Now we can, like a console, print Pi4J board info, board model. Let's launch it again. Okay, as you can see, it's printed. Where is our board? Yeah, it's here. So oh yeah, actually it's printed here, but when you init your Pi4J context. It's already parsing on the hardware, and it means it works, and it works remotely. So as you can see, we install it remotely, and we no need to use any Raspberry Pi IDE systems. Okay. Multi-threading. Kotlin is very powerful language because it has coroutines under the hood. Okay. So as you can see, Kotlin has coroutines. It means a multi-threading, so you can literally create different threads, or synchronize it, work in parallel, like classes and codes. Okay. If it's not injected, make sure that your project has a coroutines. So yeah, project structure, libraries, modules, somewhere here should be, yeah, here it is, coroutines. But if somehow the coroutines not injected when you created, after you created your first project, you can inject it manually. Just Google like Kotlin coroutines Maven dependency. Yep. And here is it. And you just copy this part and inject it is one more dependency. By the way, I'll leave a link with all the explanations, all dependencies on my Git repository, and you, if you will have some questions or some difficulties, just check like that. Okay, let me yeah, the last part, just create some simple code for in. So this loop for 10 seconds. Why we need a coroutines and run blocking block? Because we will use a delay to turn off and turn on again our LED. So one more additional check. If LED output is low, it means that LED output right now it's disabled. LED output, give it high. It means turn on. Else, give it low. So what it means? If the LED light is turned off, turn it on. Else, turn it off. Okay. Here we make some delay and something like print to console. Like that. And after that, never forget to shut down your physical configuration, because even if you launch your fat jar, install it remotely to Raspberry Pi, but after you will stop it, the Raspberry Pi and all input-output will work to continue. So if you will launch a permanent loop, it will never stop. And create some function like shutdown hardware. Okay. Let output low. Set it to low state. Perfect. And call it from here. Let's launch it. We forget to init. Sorry, my bad. We forget to init let output. Okay. Actually, the main part of this lesson, how to create instances of our input-output. So digital output, set type digital output provider. Import it and create. Here is it should be a physical address of pin connector. So Gpio outputs has 40 different pins. In our case, we're using pin number 2. I'll show you later how it works physically. And let's launch it again. Perfect. It works. It works 10 seconds. 5 blinks, because each seconds you turning off or turning on your LED. It's processed with code 0. It means we did it. Congratulations. And now I'll show you how it works on Raspberry Pi. Let's do it. Okay, as you can see, this is an extension board with Raspberry Pi. Our green LED is blinking. No need to pay attention to all this stuff, wires and sensors. We will use it in our next lessons. So this is just a regular Raspberry Pi 3rd version with extension board. This is how it works.